Hello, 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 hello. Hello and welcome back. So once again, a very warm welcome to all of you. As I always keep on saying that I hope and I wish that all of you are doing fit and fine. So today in this session, we are going to discuss wave optics, all the important concepts and PYQs in this session. So without wasting even a single second, let's get to the point. So we are about to discuss Huygens theory and interference of light. So starting with the discussion, I want to take your attention on the discussion of phase and path for a wave. If we talk about a wave, if we talk about a wave, are we aware about the relation between phase and path? Are we aware about the relation of phase and path? Yeah, definitely yes. How do we represent a wave? A wave is represented something like this. A wave is represented something like this. Okay. So what is the distance traveled by the wave in one complete time period? This is what we call as the wavelength. This is what we call as the wavelength. Okay, lambda. What is this? This is lambda. Okay, fine. So this is the distance traveled by the wave in one complete time period, and how much phase it corresponds to. What phase difference it corresponds to? It corresponds to a phase difference of 2 pi. Okay. That means we can say that 2 pi phase difference or 2 pi phase corresponds to lambda path. Okay. Or let's say lambda path difference corresponds to 2 pi phase difference. Okay. Yeah. So what unit path difference corresponds to? Unit path difference corresponds to 2 pi by lambda phase difference. Now, if I talk about 2 unit path difference, we are going to multiply this factor by 2. If I talk about 3 unit path difference, we are going to multiply this factor by 3. If we talk about delta x path difference, how much it corresponds to? It corresponds to a phase difference of 2 pi by lambda into delta x. It corresponds to a phase difference of 2 pi divided by lambda into delta x. Okay, cool, nice. So here we go. This is the relation between phase and path for a wave. This is the relation between phase and path for a wave. Phase difference and path difference for a wave. Phase difference and path difference for a wave. Okay. So this is the relation between phase and path. Okay, that's fine. So let's try a numerical, simple numerical, or let me give you a simple question based on this fact. Let's say, what is the phase difference corresponding to a path difference of lambda by 3? If the path difference is lambda by 3, what phase difference it corresponds to? It corresponds to delta phi equals to 2 pi by lambda times of delta x. So what it is, this is 2 pi by lambda into delta x. Delta x is lambda by 3. So this gets cancelled out. What is the phase difference? The phase difference is 2 pi by 3. This is delta phi. This is delta phi. Okay, I hope that the point is very clear. Here we go. Let's come to the next question. Vice versa, if I talk about the reverse situation, let's say the phase difference has been given to you as 3 pi by 2. What path difference it corresponds to? So delta x can be written as lambda upon 2 pi times of delta phi. So this is lambda upon 2 pi times of delta phi is 3 pi by 2. This is delta x. Okay. So what are we left with? We are left with 3 lambda by 4. Okay, note it down. Let's take the discussion ahead. So here we go. Let's take the discussion ahead. There's a question coming in front of you. Read the question, what it says. It says that two coherent sources of light interfere and produce fringe pattern on a screen. For central maximum, the phase difference between the two waves will be. For central maximum, okay, you need to find out the condition of central maximum. So this is the screen, and these are the two slits over here. These are the two slits over here, somewhat like this, slit number 1 and slit number 2. So this is S1, this is S2. You need to find out the condition of the central maximum. What do you need to find out? You need to find out the condition of central maximum. So this is the condition of central maximum. Okay. Is there any phase difference between the two waves? Is there any phase difference between the two waves? No, there's no phase difference between the two waves. That means delta phi and delta x equals to 0. Both are 0. Okay. Cool. So the answer is 0. Now, the next question coming in front of you is from YDSC. So let's have a quick look, a quick recap on the YDSC. What was Young's double slit experiment? What was YDSC? What it used to say? What information it used to provide? It used to talk about the interference pattern from two coherent sources. Young's double slit experiment. It used to talk about the interference due to two coherent sources. What are coherent sources? Coherent sources are the sources which are having same, or let's write it technically, which are having a constant phase difference, okay, or zero phase difference. Okay, write it down complete. I'm just writing in short form. Constant phase difference or zero phase difference. Okay, so what it gives you? It gives you the interference pattern. It gives you the pattern on a screen. What we find? We find equal strips of bright and dark fringes. What it gives us? It gives us equal strips of bright and dark fringes. Okay, fine. Cool. Yeah. So what the setup looks like? The setup looks something like this. The setup looks somewhat like this. The setup looks somewhat like this. Okay. What it looks like? Let's say these are the two coherent sources. These are the two coherent sources, and different locations form different locations are corresponding to maxima and minima. Okay, so this is source number 1 and this is source number 2. Okay, this separation is D, this separation is small d, and this separation is capital D, this separation is capital D. Okay, small d and capital D. Cool. Apart from this, this is the location of maxima. This is the location of maxima, okay, or minima. Location of maxima or minima. Now, let's join this line from the center to over this point and drop a perpendicular somewhat like this, okay. Let's say this angle is theta and theta is a small. So this angle is theta, okay. This angle is 90. This is 90 minus theta, or this angle is also almost equal to theta. So you can say that sine theta for small angles, sine theta is equals to opposite upon hypotenuse. But we are saying that sine theta and tan theta are almost equal. So tan theta is going to be y by d and sine theta is going to be opposite. That means delta x, this is the path difference, okay. This is the path difference, delta x divided by small d, okay. Just a second, let's make it a bit more clear. Drop this perpendicular like this. So this is wave number 1, this is wave number 1, and what color should we take? Let's take this color or this color, okay. Uh-oh. So this is somewhat like this. So this is the phase difference, path difference between the two lines. This much is the path difference between the two lines. This much is the path difference between the two lines, okay. Wave number 1, wave number 2. So this is the path difference between the two waves. Okay, so what are we going to write? We are going to write that, let's say this path difference over here is delta x. This path difference over here is delta x. This is theta. This is theta. Perfect. So we are going to say that sine theta is opposite upon hypotenuse. That means delta x divided by small d. Okay. So from here, what do we get? From here, we get a relation of y. From here, we get a relation of y. Y is equals to delta x times of capital D divided by small d. Okay. Delta y equals to delta x times of capital D divided by small d. Okay. Have a look at this. After this, what we are going to write? What we are going to do? We are going to write the conditions of maxima and minima. So we have written that y equals to delta x d by d. Now the condition for maxima, or let's say the condition for bright fringe is what? The condition for bright fringe is that delta x equals to 2 n lambda, not 2n lambda, just simply n lambda. So what are we left with? We are left with y equals to n lambda d by d. This is the condition of maxima. This is the condition of maxima. Cool. And the condition of minima is going to be, that means what points you're going to get the maximas? You're going to get, first of all, n equal to 0. That means central maxima. N equals to 0. That means central maxima. After that, n equals to 1. You're going to get lambda d by d. N equals to 2. 2 lambda d by d. N equals to 3. 3 lambda d by d. Apart from this, we are going to talk about the condition for minima. So what's the condition for minima? Condition of minima being delta x, that means the path difference, is 2n minus 1 lambda d, sorry, just this much, 2n minus 1 lambda by 2. This is the condition for minima. Now, if we substitute the condition for minima, what do we get? We get that y, the position for minima, is going to be 2n minus 1 lambda d divided by 2d divided by 2d. Okay, that's fine. That's cool. So if you substitute different values over here, if you substitute the value of n equals to 0, what do you get? You get the position as lambda d by 2d. Apart from this, substitute n equals to 1. No. Sorry. We are going to begin n with 1. So if you substitute n equals to 1, you get this expression. If you substitute n equals to 2, you get y equals to 3 lambda d by 2d, 5 lambda d by 2d, 7 lambda d by 2d, and so on. Okay, and the discussion goes on. So now you can read the question, what the question says. Now the question becomes very simple since we have recalled the concept. So what the question says, in Young's double slit experiment, if the separation between coherent sources is halved, and the distance of the screen from the coherent sources is doubled, then the fringe width becomes what it says. The question says that separation between the coherent sources, that means d dash, is made to be d by 2 and capital D is made to be 2 times of d. D dash is made to be 2 times d. Okay, that's fine. So what it says, what's going to be the new fringe width? So you can say that fringe width is going to be lambda d dash by d dash. Okay, lambda d by d. So what it turns out to be, this turns out to be lambda into 2d divided by d by 2. So this turns out to be 4 times. This turns out to be 4 times. Note it down quickly. Okay, so here we go. Let's come to the next question. The next question in front of you is this. Read the question, what it says. In Young's double slit experiment, if there is no initial phase difference between the light from two sources, a point on the screen corresponds to fifth minima has a path difference of. Now they are talking about the path difference. So what is the expression for path difference corresponds to maxima or minima? We write that y equals to delta x times of d by d. Is it? Isn't it? Definitely yes. This is what we have written. This is what we have written. Okay. So now what we need to find out? We need to find out the path difference. We need to find out the path difference has a path difference of how much? Now you know that what is the expression for lambda? The expression for lambda is 2n minus 1. Expression for y is 2n minus 1 lambda d by 2d. Okay, so if you substitute 5 over here, this is 9 lambda d by 2d. Okay, 9 lambda d by 2d. Equate it with delta x d by d. So what are we left with? We are left with this d by d gets cancelled out, 9 lambda by 2. We are left with 9 lambda by 2. Okay, this is the answer. Okay, this is the answer. Let's take the discussion ahead. Next question in front of you is this. Read the question. In a double slit experiment, when light of wavelength 400 nanometer, was used, the angular width of the first minima formed on the screen 1 meter away. Okay, that means d was given to you as 1 meter, wavelength has been given to you as 400 nanometer. The angular width is found to be 0.2. That means theta in this case is given as 0.2 degree. Fine. Now the entire setup is made to be immersed in water. What happens? We know that if you immerse the setup into water, the lambda changes according to the expression. Lambda dash is lambda by mu. So beta changes accordingly, and therefore theta changes accordingly. Beta is lambda d by d, and theta is simply beta by d. That means lambda by d is theta. So in short, theta dash is going to be theta by mu. That means 0.2 divided by mu. Mu is 4 by 3. What are we left with? We are left with 0.15. This is the answer. This is the answer in front of us. Okay, is this point very clear? Well, let's take the discussion ahead. The next question in front of you is this. Read the question, what it says. This question says that in Young's double slit experiment, the separation between the slits is 2 millimeter. The wavelength of the light used has been given to you, and the distance d on the slit and screen is found to be capital D has been given to you. It is found that the angular width theta, this is this much. To increase the angular width to this much, what should be the value of small d? Okay, so you know that lambda, right now you have seen, is inversely proportional to d. So you can say that lambda 1 by lambda 2 equals d2 by d1. Okay, so simply d2 could be written as lambda 1 by lambda 2 times of d1. So what are we left with? We are left with lambda 1. How much is lambda 1? Oh, sorry. You need to find. You need to comment on theta. Just sorry. Theta is inversely proportional to d, isn't it? Lambda d by lambda by d. This is theta. So theta 1 divided by theta 2 equals to d2 divided by d1. Okay, that's fine. So d2 is equals to theta 1 by theta 2. That means 0.2 divided by 0.21 times of d. How much is d? 2 millimeter. This is how much? This is 4 divided by 2.1. That means it's going to be nearly 1.9. It's going to be nearly 1.9. Note it down quickly. Done with this? Okay. The next question coming in front of you is this. Have a look at the question. Young's double slit experiment is performed in air. Fine. So let's call performed in air and then in a medium other than air. It is found that the eighth bright fringe in the medium lies where the fifth dark fringe lies in air. Eighth bright of medium lies where the fifth dark fringe of air lies. Okay. What is the eighth bright? What is the location of eighth bright fringe for any medium? That's n lambda d by d divided by mu, because since we are talking for any given medium. Okay. This has to be equal to 2n minus 1 lambda d by 2d. Okay. So from here, what do we get? This gets cancelled out. So we are left with mu equals to 16 by 9. This is going to be 1.7 something. 1.7 something. So the answer is going to be D. I hope that the point is absolutely clear. Okay. Let's take the discussion ahead. The next question in front of you says that the intensity at the maximum in YDSC is I naught. Distance between the slits is 5 lambda. where lambda is the wavelength of the light used. Okay, fine. What will be the intensity in front? What will be the intensity in front of one of the slits on the screen placed at a distance of 10d? See what this question says, what this question tries to say. This question wants to say that see, these are the two slits. These are the two slits. Okay, fine. And you're talking about a location exactly in front of the slit. Okay. This is what the question says. The intensity at the maximum of YDSC is I naught. Okay. Distance between two slits is this much. Lambda is the wavelength of the light used in the experiment. What will be the intensity in front of one of the slits? So let's say this is slit number 1, this is slit number 2. You need to find out the intensity at this location. You need to find out the intensity at this location. Okay. And what is this distance being given to you? This is D. This distance being given to you, how much? This is capital D. Okay. Now see. This, sorry. This is the case of maxima, the initial case of maxima. Apart from this, what you're talking about? You're talking about a condition something like this. Okay. This is what you're talking about. The intensity at this central location has been given to you I naught. So you know what's the expression? I equals to I naught cos square of phi by 2, isn't it? Now they are talking about the intensity. They are talking about the intensity. What are they talking about? They are talking about the intensity in front of one of the slits. Okay, that means over here at this location that I'm highlighting. So. Yeah, so we can find out the path difference corresponding to this point, isn't it? We can say that what is the expression of y? Y equals to delta x times of d by d. So delta x can be written as y times of d by d, isn't it? So corresponding to this situation, corresponding to this situation, what can you say? You can say that there is going to be a certain path difference. How much is that path difference going to be? That path difference is going to be y, that's d by 2. Y is d by 2 times of d divided by d, and d has been given to you as 10d. D has been given to you as 10d. Just a second. Delta x is y d by d. Y is d by 2. That's fine. Yeah, okay, fine. So what are we left with? This gets cancelled out. And then small d is 5 times of lambda divided by 20. So this is lambda by 4. Delta x is nothing but lambda by 4. So once we found delta x, we can find delta phi. We have found delta x. We have found the path difference. So now what we can do? We can find out the phase difference. That's going to be 2 pi by lambda delta x. So how much it turns out to be? It turns out to be 2 pi by lambda into lambda by 4. This is nothing but pi by 2. So if delta phi, that means the phase difference, is pi by 2. So what's the expression going to be? Pi by 2. Okay, phi is pi by 2. So phi by 2 is 45 degree. So cos square 45 degree. That means 1 by root 2 square. That's I naught by 2. This is the answer. This is the answer in front of you, okay? I not but the answer. Note it down quickly. Okay. Let's come to the next question. The next question, use this, read the question. Interference pattern is obtained with two coherent sources of light and the ratio has been given to you for I1 to I2 being given to you as n. I1 is to I2 being given to you as n. The interference pattern I max minus I min upon I max minus I min. How much is this going to be? What is this expression going to be? First of all, what is I max? That's root I1 plus root I2 the whole square. So you can simply write it as I1 plus I2 plus 2 root I1 root I2. Similarly, what's going to be I min? That's going to be I1 plus I2 minus 2 root I1 root I2. Okay, this is going to be the expression. Now what you can do? You can find the value of I max plus I min and I max minus I min. Okay, so if we figure out what's I max plus I min, it's going to be add up both these equations. This gets cancelled out, so you're left with, oh, initially it's I max minus I min. No worries. Let's figure out I max minus I min. Okay, let's figure out I max minus I min. If you subtract both of them, this I1 I2 gets cancelled out, so you are left with 4 root I1 I2. What is I max plus I min? What is I max plus I min? What is it going to be? It is going to be how much? It is going to be, add both of them, 2 times of I1 plus I2. Okay, 2 times of I1 plus I2. So this turns out to be 2. Take this in division. You are left with 2 divided by root over, divide it over here, I1 by I2 plus divide it over here. This would be root over I2 by I1. So root I1 by I2 is n and root I2 by I1 is 1 by n. So this is 2 divided by n, sorry, root n plus 1 by root n. This is the expression. This is how much? This is 2 times of, this is 2 times of n, 2 root n upon n plus 1. 2 root n upon n plus 1. This is the answer. Okay, note it down quickly. I hope that the point is clear. So let's take the discussion ahead. There's another question coming in front of you. What this question says: in a double slit experiment, the slits are 1 mm apart while the screen is placed 1 meter away. Small d, 1 mm, 1 meter, 500 nanometer. The width of each slit for obtaining maxima of double slit when the central maxima of single pattern. What it says, what will be the width of each slit for obtaining 10 maxima of double slit within central maxima of single slit. That means within the central maxima of single slit, how much is the width? 2 lambda d by the, let's say the slit width is A. This is for central. This is for central maxima of single slit. This must be equal to 10 maximas, 10 lambda d by n lambda d by d. Okay. So from here, you get the relation as what you need to find out. You need to find out what will be the width of each slit. Each slit, that means D equals to okay, this is small d. Sorry, this is small d. You need to find out A. So A is equals to, this is 1 mm. So A is going to be equals to this is going to be how much? This is going to be 5. So this is 1 by 5 mm. That means 0.2 mm. 0.2 mm is the answer. Okay, is this point clear? So I hope that the discussion for today is absolutely clear. Now let's continue the discussion in the next session. Until then, take care. Goodbye. See you all tomorrow. Bye bye.